A very good morning, dear children. Today we will continue with the remaining part of Chapter 3, Chemical Reactions and Equations. You can see different pictures on the screen. And if you carefully pay attention to it, you will understand that the rate at which these reactions are happening are different. Which means that every chemical reaction has certain factors which determine whether it's going to take a long time for these reactions to happen or whether the reaction will be very quick. So what we are going to discuss today are the factors that affect the rate of a chemical reaction. The first is nature of the reactant. On the left hand side, we have shown a test tube where zinc is reacting with hydrochloric acid, and on the right hand side it's aluminium reacting with hydrochloric acid. And it's clearly visible that aluminium shows a rapid reaction with the same acid, whereas zinc is taking time. This indicates that the nature of the reactant plays a vital role in determining the time that is taken for the chemical reaction to occur. Aluminium is mostly reactive as compared to zinc. Aluminium is more reactive than zinc, and that is why the rate of reaction of aluminium with hydrochloric acid is higher than that of zinc. The nature or the reactivity of reactants influences the rate of a chemical reaction. Size of reactant. On the left hand side, we have a piece of shahbat tile, and on the right hand side, we have crushed or pieces or powder of the same material. You will see that the right hand side reaction shows rapidity, or it is happening rapidly, whereas it is taking time for the reaction with a big piece. This indicates that the size of the reactant matters. Same reactant, when it is in the powdered form, the reaction happens rapidly. So, the rate of the reaction and the size of the reactant are indirectly proportional. More bigger the reactant, the more time it will take. Smaller the reactant, the more rapid the reaction will be. Concentration of the reactant. Here, two test tubes are taken. On the left hand side, the test tube is magnesium and a dilute acid. And on the right hand side, we have magnesium and a concentrated acid. And it's clearly visible that the reaction is rapid when concentrated acids are used. Concentrated acids react faster than the dilute acid, which means that rate of the reaction is proportional to the concentration of the reactant. Temperature of the reaction. Most of the reactions do not take place at very low temperature or very high temperature. Reactions take place at temperatures which are in the middle range, not too high, not too low. Every reaction happens at a specific temperature, which means every reaction has optimum temperature. That is the temperature at which it is the quickest. Catalyst. The substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it is called as a catalyst. As you can see, a catalyst is a green colored substance on the screen. When this catalyst is added into a reaction, it is helping to bring the two reactants together such that the product is formed quickly, but the catalyst is not getting affected. On heating potassium chlorate, it decomposes very slowly. But this potassium chlorate decomposes rapidly in the presence of manganese dioxide to liberate oxygen gas. No chemical change takes place in manganese dioxide in this reaction, and that is why it proves to be a catalyst that helps in increasing the rate of the reaction. Now coming to oxidation and reduction. First, we'll look at oxidation. The chemical reaction in which a reactant combines with oxygen or loses hydrogen to form products is called as oxidation reaction. Let us look at examples. First, magnesium reacting with oxygen to give magnesium oxide. Here, oxygen is combining with magnesium to give rise to magnesium oxide. So there is acceptance of oxygen happening in the first reaction. Second, carbon reacts with oxygen to give rise to carbon dioxide. Here again, oxygen is combining with carbon to give rise to carbon dioxide. Here again, oxygen is gained or oxygen is combining. Magnesium hydride loses the hydrogen and it releases magnesium. Here, in the third reaction, hydrogen is lost. Ethane giving rise to ethene. Here, CH3 is getting converted to CH2 in both the cases. What is happening is CH3, that's the first group, is losing one hydrogen to get converted to CH2. Similarly, the second group CH3 also loses hydrogen to give rise to CH2. So again here, hydrogen is lost. Ethanol getting converted into acetic acid. Here if you see, the H2 group is lost and in its place oxygen is taken. Here oxygen is being provided by potassium dichromate. Such a substance that provides oxygen so that oxidation can happen is called as oxidant or oxidizing agents. We have many oxidizing agents like we have potassium permanganate and sulfuric acid. Similarly, potassium dichromate and sulfuric acid. So these are called as oxidizing agents because they provide oxygen for the oxidation reaction. So if you look at the screen, the first two example is where oxygen is gained, whereas the remaining reactions are where hydrogen are lost. Even though hydrogen is lost or oxygen is gained, all of them come under oxidation reactions. Now coming to reduction reaction. The chemical reaction in which a reactant combines with hydrogen or loses oxygen to form products is called reduction reaction. In simple terms, it's opposite to oxidation reaction. Let us look at examples. Mercuric oxide loses oxygen to form mercury. Here, oxygen is not gained, but oxygen is lost, and that is why this becomes an example of reduction reaction. Redox reaction. The chemical reaction in which oxidation and reduction is happening simultaneously is called redox reaction. Let us look at examples. Here, CuO plus H2 gives Cu plus H2O. Now, if you're looking at the first reactant, that is copper oxide, it is losing its oxygen. Losing oxygen means reduction. And hydrogen is gaining oxygen. Gaining oxygen means oxidation. So reduction is happening, oxidation is happening, and that is why this becomes a redox reaction. Similarly, H2S plus SO2 gives S plus H2O. Here, sulfur dioxide is losing its hydrogen, it's losing its oxygen. Because it is losing oxygen, it is a reduction reaction. This oxygen is gained by hydrogen. Because it's gaining oxygen, this becomes oxidation reaction. So there is reduction, there is oxidation happening together. So this is a redox reaction. Now coming to corrosion. What is corrosion? Because of various components of the atmosphere, oxidation of metals takes place, consequently resulting in the damage of the metal. This is called as corrosion. Rusting of iron is an example of corrosion. Here, 4 test tubes are taken. In all the 4 test tubes, an iron nail is placed. In the first test tube, along with the iron nail, we have boiled water and a layer of oil on top. In the second test tube, along with the iron nail, we have salt solution. In the third test tube, we have only the iron nail, but the test tube is open, which helps air to enter into the test tube. The fourth test tube is where, along with the iron nail, we have calcium chloride and the test tube is closed. So if you carefully look at it, we will see rusting of the iron in the second and the third solution, second and the third test tube. In the second test tube, what is happening is the salt solution causes the corrosion to happen or rusting to happen. And in the third test tube, the air is in contact with the iron nail, so there also you will see corrosion. But in the first test tube, the water is boiled, and secondly, the oil layer is going to prevent the interaction of the water with the air. So there you will not find rusting. Similarly, in the fourth test tube, the calcium chloride absorbs the moisture in the air, and because the test tube is closed or it has a lid, there's not going to be any kind of interaction of air with the iron. So in the fourth test tube also, there won't be spoiling of the metal. We see corrosion in many other different places, like silver gets corroded and it has a black surface on it, it has a black layer on it. Similarly, Statue of Liberty is another example of corrosion. Rancidity. When we use old leftover cooking oil for making foodstuff, it is found to have a very foul odor, and that is called as rancidity. If the food is cooked in such oil, its taste also changes. When oil or ghee is left aside for a long time, or the fried food is also left aside for a long time, it undergoes oxidation and becomes rancid. Rancidity in the foodstuff cooked in oil or ghee is prevented by using antioxidants, or even the process of oxidation can be slowed down if you are putting or storing these materials in airtight containers. So I hope what was explained today was clear. Thank you.